This is a tough but really interesting question. We've got 5 faces of a cube and we're trying to work out what the other one could be. And we know that there are 15 black cubes in total and 12 white. Now I'm going to focus on the black cubes. I think in the solutions they do the white cubes, so it's worth reading about that as well, but I'm going to stick with the black cubes. Um, well, one thing to notice is that this one here is in the center of a face, so it's only going to get counted once, whereas the ones on the corners are going to get counted 3 times because they're going to appear on 3 of the faces, and then the other ones on the edges, I suppose, are going to actually get counted twice. I'll come back to that in a minute, but the first one then is to look at the middle, and we see that we've got 4 cubes in the middle. So remember, we're counting them up to 15. Now I'm going to look at the corners. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 squares on the corners. So overall, we need a multiple of 3. So there must be 0 or 3 squares shaded on the 6th face. Now, none of them have 0, so actually it's got to be 3 in our case, which means we can rule out a few of them already, B, C, and D. So actually it's only between A and E. So from above must be 3. We might have run into problems anyway. If we'd had 0, I'm not sure. No, maybe not. Maybe it would have been possible. Um, but what that's going to mean is that we've got 18 squares, and so we're going to get 6 cubes. Okay, now we can't rule out another one being in the middle, but let's have a look at the others then. So for the others, I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 squares on the edges. So this is going to be 4 cubes so far. And that would take me up to 14 overall. So either we're going to have 1 in the middle on the 6th face, and 0 on the edges. Remember, we have to have 3 on the corners, but what we're saying is like you could have 3 on the corners in just in theory. We've not actually shown that it's possible, but we could put 3 here in theory, and then put 1 there, because that would give us 4 in the middle on the other ones, then a fifth, and then we've got 6 cubes from here already, including these corners, so up to 11. And then from the ones on the edges, we've got another 4, so that would take us to 15. So that would be possible, but that's not actually one on any of the answers. So the other option is 0 in the middle and 2 on the edge. Putting 2 on the edge will actually mean we get an extra cube. So let's take a look at the final answer, the ones that are left. This one has one in the middle, but it's also got some on the edge. So actually E is not possible. Whereas A has got three on the corners, and then it does have these two here. So if it's going to happen, then the sixth face must be this cube. Now that is a tough question, I think. One thing that I looked at when I did it is that I saw that there's like a row of three here, and three here. And so in the final answer, there must be a three somewhere for it all to match. And so that is another way of ruling out C and D. But then I kind of got a bit stuck and I went on the wrong track actually, because I didn't use the fact that you have to have, um, 15 black cubes. So I hope this makes sense. Really, really nice question and approach. The one thing we've not actually done is we've shown that out of the five, if it's possible, then A is the only one that would work, but I've not actually shown that it will work. Um, and I had to play around with this. I can't just do it in real time now, but I'd managed to fit them all together. So if you made this net, then it would all match up, and I've forgotten which one it is. It's this one with 3 and 2. So it's that very top one here that I've added. And you can kind of see I'm going to sort of match actually some of the edges up. So when you fold this together, they'll match. And these two will match. Um, and then, yeah, sorry, let's keep going around here. That's quite a good shout. Hit these two, these two. When I fold this in, this one is going to match with that one. And then the hardest ones to kind of see, I think, when I fold this in and up, it is going to match with that one, which just leaves the remaining one. This one and this one will match as well. Okay, so that's pretty cool. Not required for the problem, but it's quite interesting to see how it would work. All right, well done with this and the challenge overall.